Welcome to queenon7.com. Please like, share and subscribe my video. Today we're going to learn about the bond enthalpy or bond energy calculation. We have done the exothermic and endothermic reactions where you actually looked at how the reaction is going to happen. I'm going to give you a brief description how the endothermic and exothermic happens at the same time, but how we can actually look at the overall reaction to predict whether it is an endothermic or exothermic reaction. Now look at the bond energy. Bond energy means the energy required to break or make the bond in chemistry. For example, if I will say you will have H2 plus Cl2 and you're making 2HCl, that too is to balance the equation. So in a balanced equation, you will look at the type of bond. Now when you have atoms together, both of them will never ever actually react straight away. Most of them, they don't react straight away. You have to provide them some sort of minimum energy, which we have discussed in the previous video, that it is called an activation energy. Now hydrogen, I can actually write it like that: hydrogen, hydrogen, chlorine, chlorine, and I can write it down like this: hydrogen bond Cl. That means that these two, before they convert into HCl, I have to break this bond to make them into the atomic form so the atoms can actually react together. Now to do that, on this side of the arrow, you need to remember, as a GCSE student, on the left hand side you always actually provide the energy. So that you provide the energy to break the bond. To break any bond in chemistry, you have to give the energy in the system. So this side you will say energy in. Energy in means is endothermic. Other side, this is called bond breaking process. So bond breaking process, if it's a 1 marker question, it is actually an endothermic process. On the other side, to make this bond, this will actually release energy, so energy out of the system, and it is called exothermic. Everything reverts from the reactants. Now, because you are making new bonds, and that is called bond making process. Now, if it is a 1 marker question in GCSE, you can actually completely say that the bond making process is an exothermic reaction, and the energy which is going to come out is going to be in negative. Here, the energy is going to be positive. Okay. Now, we're going to calculate the bond energy for this reaction to understand how we can actually calculate it. First of all, you need to understand that the formula to calculate the change in the energy on this side and on the other side, so the reactant's energy minus the product energy, can actually tell you that whether it is an exothermic or exothermic reaction. Now, delta H is equal to energy of reactants minus energy of the products. Now, to calculate that, reactants, to break this bond, they always give you a table. To break HH bond, you need 436 kilojoules per molar energy. Because it is only one molecule, so I don't have to times it by anything, it's just 436. Plus, on the reactant side, you have another molecule called chlorine. For chlorine, you have to have 243 kilojoules per mole energy. Because it is only one molecule, 1 mole, so I do not have to times it by anything. So this is the energy of the reactants. Then you will put minus there of the product. So at the moment we have only one product, but you can have more than one product. HCl, if you want to break this bond, you will actually have 432 kilojoules per mole of energy required to bring H and Cl bond. So to make that HCl bond, 432 energy will come out. Now you have to times it by 2, because when you balance the equation, it is actually 1 mole of hydrogen and 1 mole of chlorine producing 2 moles of hydrochloric acid. So that's why you have to times it by 2. So this energy will be times by 2 based on the number written on this side. Now the answer, when you're going to do that, reactants, and this is product, and that will be the actual delta H of the answer of all of this is it actually should be more than in the minus form. So I'm not actually sure how much it's going to be, but it will be in minus the whole answer. I can solve that for you if you want. So this one is 9 and 7 and 6 on the right hand side, minus you have 4, 6, 8. Look at this value. This is 679 and this is 846. Because this is the bigger value, you will have 5, and then you will have from here 5, 8, and then you will have 1. So 185 minus 185 kilojoules per mole of energy. Now, because the answer came in negative, that will actually predict this is an exothermic reaction.